Welcome to this tutorial. I am solving question number 9 of paper 21 May-June exam series of 2022 in this tutorial. The topic of this question is radioactivity and half-life. Question says table 9.1 shows details of 7 different nuclides. Hydrogen 2 radiation emitted none, no half-life is here. Hydrogen 3 it emits beta radiation and the half-life is 12 years. Francium beta 22 minutes, iridium 192, gamma 74 days, phosphorus 32, beta 14 days, radon 222, alpha 4 days, technetium 99, gamma 6 hours. Hydrogen 2 and hydrogen 3 are isotopes of the same of the element hydrogen. Define the term isotopes. So we define it atoms of the same element which have same number of protons but different neutrons. The equation for the decay of phosphorus 32 P32 as it emits a beta particle is phosphorus 3215 by emission of one beta particle gives an element Q whose proton number is 16 and the mass number is 32. Explain whether the equation shows that Q is another isotope of phosphorus. Q is not the chemical symbol for the atom. We can see that both elements have different proton numbers. One is 15 and for the other one it is 16. Since the proton number is not the same, so that is why they are not isotope. So we would write it is not an isotope because Q has a different proton number. The next part says one of the sources in table 9.1 is used in a medical procedure to detect unusual bone structures. It is injected into a patient and the radiation emitted is detected outside the body. State which source in table 9.1 is most suitable for this type of medical use. So the most um, appropriate source would be this last one, technetium 99, because it is emitting gamma radiation, and secondly it has a half-life which is very suitable for the medical procedures. So the answer here would be technetium 99. Next part says explain two reasons for your choice. So the first reason is that half-life of 6 hours is long enough to examine the patient and gamma rays cause less damage because their ionization power is low. They have good penetration power, so they come out of the body also too quickly. The next part says radon gas is one natural source of background radiation. Some causes of background radiation are man-made, for example X-rays. State one other natural source of background radiation. So it could be rocks. State one other man-made source of background radiation. Nuclear power stations where nuclear fission is happening. State one harmful effect of background radiation. It can cause cancer. One fusion reaction that occurs is hydrogen 2,1 combines with hydrogen 3,1 to give helium 4,2 and some other product. Complete the equation to show the missing proton and nucleon number. So for the protons, we have one proton and one other proton in both the reactants, and both of them are combined in helium, and the proton number of helium is 2. So they are already balanced. So we have for neutrons one neutron over here and two neutrons in this element. So we have 3 neutrons here. 2 of them are included in helium because the nucleon number 4 shows that there are 2 protons and 2 neutrons. So one neutron is left. That one neutron would be shown here. So for a neutron, we do not have any charge on this neutron, and the mass number for neutron is 1. So 1 and 0 would be written here. Deduce the name of the particle X. So it is a neutron. Suggest where this fusion reaction takes place. So it takes place in the sun or stars. Compare the properties of alpha particles and beta particles in terms of their ability to penetrate through materials, ionizing effects, deflection in a magnetic field. And the reasons are alpha particles, they are larger in size, heavier particles, so they are even stopped by a thick sheet of paper. Alpha particles have larger charge, so they cause more ionization. Alpha particles are heavier, so that is why they are difficult to deflect, and for the same speed they show less deflection, while beta particles are very lighter particles like electrons, so they show larger deflections in the magnetic field. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.